Alright, hello again. So we're going to spend a few minutes talking about interactions between two quantitative variables. And so remember where we kind of left off was we had talked about an interaction between a quantitative variable and a categorical variable with that Wines data set. We saw that an interaction meant that the relationship between wine quality and chlorides depended on the wine type. And so now that both of our predictors are going to be categorical or quantitative, we're going to see how that's going to change a little bit, but how the flavor of the interpretation is really going to remain the same. And so we've got some data on using strength of something as a response. And so this was some manufacturing process. I don't remember the details on what the product was, but it wasn't that exciting. And so we're interested in modeling the product strength as our response with a few different predictors. So we've got pressure, so the pressure that the product was made under, the temperature, and the time, as well as this pressure-temperature interaction. And so that's this first model on the top. We can also compare this to a model without the interaction term. So a model with strength as the response, but just pressure, temperature, and time as predictors. And so let's go ahead and locate the coefficients for pressure and temperature for each of the two models. And just make a note for now that they're super, super different. So our coefficients are just like super different. And so they're different because this interaction term here, as we're going to see, really throws off the interpretation of the coefficients for the individual terms. And so let's go ahead and delve into that a little bit farther. And so in general, we usually don't interpret the main effects, so the coefficients for the non-interaction term, in a model that has an interaction in it. So one reason why would be our usual interpretation might sound something like, okay, so maybe we want to interpret the coefficient on pressure, this negative 11.52. We might say for a 1 unit increase in pressure, we expect mean strength to decrease by 11.52 units if temperature, time, and the interaction of pressure and temperature don't change. So what doesn't make sense about that interpretation? So you might want to take a second to pause the video and think for a moment about why that doesn't really make sense. Okay, did you pause it? For real? Okay, I trust you. So, what doesn't make sense about that interpretation is that, like, we're saying we're increasing pressure by 1, but then we're saying, okay, but the interaction of pressure and temperature doesn't change, and that just by definition doesn't make any sense. And so we're saying at the beginning of that interpretation that we're increasing pressure by 1, but that the interaction between pressure and temperature, which is just a multiplication between pressure and temperature, doesn't change, which makes no sense. We can't have pressure go up by 1, but then say that the multiplication between these two things doesn't change at all. That just doesn't really make much sense. Okay, and so we're seeing that the coefficients are much harder to interpret. What we can do instead is interpret the coefficient for pressure at a fixed value of temperature. or vice versa. We could interpret the coefficient for temperature at a fixed value of pressure. So for example, we might want to interpret this pressure coefficient when the temperature is fairly low, and again when the temperature is fairly high. To see what our range of temperatures is, I've just gotten a summary of this temperature variable. So we see that the minimum is 93, the max is 113. So when the temperature is 95, let's write out what the model is going to be. So we're going to have our intercept, our slope with pressure, and now I'm just throwing in a 95 for temperature. So again, we want to make this interpretation for a specific value of temperature, pretty much because that's the only way we could do it. And so again, I'm going to throw in a 95 here because this is the interaction term. And then what I'm going to do is I'm going to group these like terms for pressure. So I'm going to group this negative 11.52, group this 0.121 times 95. So our coefficient for pressure is going to turn out to be negative 0.025 when the temperature is 95 degrees. So we'll pick this up in the next video. You can try this similar calculation for when temperature is 110. So in the next video that will just be written down, and we'll go from there.